Hello and welcome to ISV Considerations for Azure Landing Zones. I'm Michael C. Bazarewski, your host for this presentation. I'm an engineer in the Fast Track for ISV and Startups team here within Microsoft, where I help independent software vendors, ISVs, and startups in their journey to successful deployments on Azure that follow our best practices. This presentation covers content that is documented in Microsoft Learn, primarily at http://multitenancy/ISV landing zone and related pages. If you're the type of learner that prefers written documentation to videos, you might find that more useful than this video. With that, let's get into it. To start, let's talk about what exactly a landing zone is. The Cloud Adoption Framework defines a landing zone as an environment that follows key design principles across 8 design areas. These design principles accommodate all application portfolios and enable application migration, modernization, and innovation at scale. But what are those 8 design areas? Those 8 design areas are Azure Billing and Microsoft Entra Tenant Considerations, Identity and Access Management, Resource Organization, Network Topology and Connectivity, Security, Management, Governance, and Platform Automation and DevOps. We'll get more into the details of each of these points later in this video. A landing zone ends up looking something like this once it's fully deployed, but don't feel overwhelmed by this. Even though this is directly out of the documentation and there's a lot of components pictured, it's easy to potentially feel overwhelmed at first. But don't worry. Although ultimately you end up with a sophisticated result, something that's able to handle your workload successfully, it's possible to either use templates to help with deployment or to build the landing zone up in stages, avoiding the fear of being lost in the details of the solution. Most of the landing zone documentation is targeted primarily at enterprises. However, that doesn't mean an ISV can't use it as well. For an ISV, their view will be tied to their multi-tenancy design. Multi-tenancy refers to the idea that instead of targeting one customer, the enterprise itself, the solution targets many customers, each of which is running the ISV's software. For example, consider GitHub. GitHub hosts open source repositories for a large number of customers, from individual open source developers such as myself, up to large enterprises such as Microsoft. GitHub, in a way, in this multi-tenancy scenario, is acting like an apartment building. Each of the customers in that apartment building can be referred to as a tenant, just like how a renter in an apartment building can be referred to as a tenant. In this model, each of the customers of GitHub, like me or like Microsoft, act as the renters or act as the end users of the solution, while the developer or the organization that created GitHub acts as the apartment building. So essentially, GitHub acts as the hosting facility for the tenants. Now, in this model, we're talking about a software as a service model or SaaS model. The ISV landing zone guidance clarifies the multi-tenant designs for SaaS into 3 broad categories: pure SaaS, customer deployed, and dual deployment. Let's break this down a little bit. For a pure SaaS model, everything is deployed in the ISV's subscription. The ISV customer is accessing resources in a subscription owned and managed by that ISV. The management and control plane in Azure is not delegated to or accessible by the customer in this model. Instead, everything is managed by the ISV from an Azure viewpoint, and only the workload is accessed by the customer. This is how, for example, GitHub and Microsoft Teams work. In this situation, the software is running in GitHub's subscriptions or Microsoft Teams subscriptions. In the second model, the customer deployed model, the customer is deploying the resources in their subscription. paying for the Azure resources in use directly, and then generally paying an application use fee to enable the deployed resources. For example, most third-party Azure firewalls, such as those from companies like Sophos, Qualys, or Fortinet, follow this model. They are virtual appliances, virtual machines running in the customer's environments. These machines run custom VM images, which are billed either directly through the Azure Marketplace or activated with a license key, something like that, to enable their functionality. In this model, customers are usually deploying from the Azure Marketplace, which allows the ISVs to control the deployment process and control updates to the images and those kinds of things. In a dual deployment or SaaS hybrid model, we're combining both of those previous designs into a single design, where the ISV managed components are connected to the customer's components, typically through networking. For example, consider Azure's on-premises data gateway. The on-premises data gateway architecture, as pictured here from the documentation from Microsoft Learn, shows that there's an on-premises software package installed to facilitate sending data to the cloud-hosted services for integration scenarios. There are portions running in hosted Azure environments and portions running in the on-premises environment. In general, hybrid designs tend to follow this idea of on-premises resources that are connected with cloud resources. So that's the three basic SaaS designs: pure SaaS, customer deployed, and dual deployment. But how does that relate to the 8 design areas mentioned before? I'm going to take some time to go through this in detail now. First, we're going to start with the Azure billing and Microsoft Entra tenancy. Azure subscriptions by design must be associated with Microsoft Entra tenants. More specifically, it's a many-to-one relationship. Each subscription is associated with a single Microsoft Entra tenant, or collection of users and groups, and a single tenant can host 0 or more subscriptions. The tenant acts as the authentication and authorization layer for the Azure management and control plane. Meanwhile, subscriptions have a one-to-one relationship with billing configurations. So each subscription has associated with it a monthly bill. That monthly bill is covered by whatever billing is configured for that subscription. These two concepts together mean that billing is ultimately controlled by users in the Microsoft Entra tenant that is associated with the subscription in question. Taking this to the 3 SaaS models, in the pure SaaS model, the ISV has all of the billing happening in their environment, controlled by them with their Entra tenant. The ISV then decides how to translate that to a customer bill. There's many ways to do that, including a cost-plus model or a metered consumption model, such as per user, per gigabyte, or whatever meter makes sense. The point is that the billing directly from Azure is to the ISV, while in the customer deployed model, the bill for Azure is handled by the customer. And as previously mentioned, the ISV bills either through Azure Marketplace billing or an external billing model, such as a license key purchase. Finally, in the dual deployment model, we have both billing on the customer side and on the ISV side, because part of the solution is in a subscription billed to the ISV, while the remainder is in a subscription billed to the customer. Moving on to identity and access management, this also depends on the deployment model. As mentioned earlier, the Entra tenant for the Azure management and control plane is going to be tied to the deployment model because the hosting subscription is tied to it. However, this is separate from the actual application workload. It's important to understand that it's possible for the workload to have its own authentication configuration, which may be tied to the subscription tenant. For example, in Azure App Services, where it's possible to do this very easily to configure authentication against the tenant. Or it may be internal to the application configuration using a library such as the Microsoft Authentication Library to authenticate against a specific Microsoft Entra tenant at the customer or an ISV managed Microsoft Entra tenant, perhaps with external identities such as B2B, business to business, or B2C, business to consumer, configured, or they could be completely internal identities, such as the legacy model of an identity database managed by the application. As a best practice, an application configured either as a Microsoft Entra multi-tenant application or an external identity application should be considered so that the ISV no longer has to own the full end-to-end security of the identities and can leverage built-in capabilities such as multi-factor authentication. Also, many customers already have Microsoft Entra tenants, which allows leveraging their existing identities and identity management instead of needing to have them manage a new set of identities. As an example, consider how Exchange Online allows signing in directly with a customer's tenant, while SharePoint Online offers external document sharing through B2B. Next up in the design areas is resource organization, which is a governance-adjacent topic. As mentioned with billing, resource organization includes how resources are deployed to subscriptions, and the deployment model is defined by that subscription deployment at a fundamental level. However, besides the question of subscription ownership, ISV, customer, or blended, there's also the question of how to organize resources inside the subscription. When deploying to Azure, every resource must be deployed in what's known as a resource group. An Azure resource group can be deployed as a unit and can be deleted as a unit. Furthermore, it's a level for role-based access control, or RBAC. Deploying a managed application from Azure Marketplace will actually deploy it into a resource group and take advantage of that RBAC capability to protect the marketplace managed assets using a system-assigned deny assignment to prevent manipulation of the resource group hosting the managed application. Furthermore, resource groups can be used as a dimension on Azure billing reporting. All of this ultimately means that when ISVs have to deploy a consistent set of per customer resources, they will generally do this with one resource group per customer. Resource groups are sometimes part of a best practices pattern referred to as deployment stamps. In a deployment stamp model, or deployment stamp architecture, different customers are spread across different deployment stamps, which are independent instances of the system. They may be deployed across different regions, different geographies. The details of deployment stamps are outside of the scope of this video, but are covered in the linked Microsoft Learn documentation. Moving on, the next design area is network topology and connectivity. When we talk about that piece, the key thing to focus on is to properly isolate network resources between customers. Very often, there's no shared resources between customers, or very carefully controlled shared resources. In the case of the customer deployed model, network isolation and topology are ultimately the customer's concern. But you must supply the customer appropriate information on when it's needed and why. If you don't supply the why, their security team might reject you wholesale, as well as the flexibility should be allowed to integrate properly with the existing customer environment. For example, hard coding IP addresses is a sure way to lead to unnecessary friction and deployment failure and dissatisfaction with your customer. In the case of a dual deployment model, it's necessary to consider how the integration between the customer's environment and your environment will be handled and how it will work. For example, this may be done through an API layer that runs in Azure that is accessed by the customer's deployment in Azure or even potentially on premises. In this kind of configuration, you'll want to consider how the security will work. This could be something simple like the customer supplying source IP addresses and using Azure Firewall to limit access to the Azure hosted resources based on those IP addresses. Or it could be more sophisticated and use something like Azure DDoS or Azure Distributed Denial of Service protection to add more security to the solution, or taking several of these as a defense in-depth mechanism. In the case of a pure SaaS model, the network isolation is still the key concern, but it's one entirely within the ISV's control. The exact network topology will depend on if there are shared resources or not. If there are no shared resources, each customer can have completely isolated environments with even identical IP addresses internally, carefully exposing only necessary access points to the outside. Resources without customer accessible components should not have a public IP address, directly or indirectly. An ISV can use back-end access paths to manage those resources, such as an Azure point-to-site VPN connection or Azure Bastion. Both of those solutions allow secured access to the ISV network by ISV individuals without exposing things to end users or to the public at large. If there are shared resources, such as a central database, it's important to use tools such as network security groups or Azure Firewall to control traffic flow. There's no need to have the ability for one customer deployment to directly interact with another customer's deployment, so isolate them from each other as much as possible. Consider a point-of-sale hardware and software provider that processes credit card payments. One design possible would be to have a central database for all the card readers in the field, tracking all hardware deployments and their associated ownership, with all transactions from those readers passing through a central processing layer that maps those field units to the appropriate retailer. Meanwhile, each retailer's individual product offering could be managed in a retailer instance of a management portal with a local pricing database. In this way, the point of sale software only interacts with that retailer's instance of the pricing information, while the hardware for the card processing only interacts with a central processing system for retail transactions. This isolates customers as much as possible while still having a secure and scalable solution. As you might expect, when talking about retail transactions, security comes to mind, and that's the next design area. I've already talked about this in different places. For example, security is part of identity and part of network design. It's going to be woven throughout the entire solution. It can't be tacked on later. Because I've been taking it through other areas and will continue to do so, I'm not going to have direct information that's just focused on security per se. Because if security is not being considered and reviewed through the development and deployment process, including concepts such as the security development lifecycle, the end result will be vulnerabilities that are hard to correct later. The earlier security is brought into the planning, the better it will be for everyone. You as the ISV, your end customers, the internet at large. The next design area is management. Management refers to how the ISV manages the solution's deployment. This includes resource utilization for proper billing, pricing, and cost management. Tools such as Azure Monitor and Microsoft Cost Management can help with this, even in a cross-cloud, multi-cloud solution. Network monitoring to ensure security is being properly enforced, such as using Azure Monitor Network Insights to watch traffic flowing in and out of the solution. removing unused resources when a customer is no longer a customer, essentially properly offboarding the solution from the environment. And finally, security management, where when we talk about security management, we're talking about things like the security features we've already mentioned. A key part of management is that as much as possible should be automated so that processes are documented, repeatable, and consistent across customers. More about this in a little bit. In the meantime, the next area is governance. There's already Azure governance information for independent software vendors at https aka.ms FTA ISV governance, and it wouldn't be appropriate to repeat that information here in depth. Fundamentally, the previously discussed concepts of identity and access management, resource organization, and management are all part of the large-scale governance picture. Please refer to that ISV governance video series for more details on governance-related topics for ISVs. The last design area is platform automation and DevOps. As mentioned earlier for management, a key part of a good ISV offering, whether hosted on Azure, on another cloud, or even on premises, is proper automation and operational practices. Aspects of this include creating an automated customer onboarding and offboarding process, which may include deleting data entries, deleting resource groups, archiving information, and sending internal notifications about status changes. Developing a full DevOps culture and pipeline that supports code updates for both planned updates and emergency updates across test environments and customer environments. This helps ensure you do not end up with customer drift. And notice I did include culture. DevOps culture is a big piece of this. This is not just tools, this is a thought process as well. In a more mature organization, developing a GitOps culture and processes may happen, which is covered, for example, at https aka.ms GitOps with Argo CD. The actual details of the automation vary, but normally this would include some form of infrastructure as code, or IAC. IAC is the idea that resources for the solution are deployed using source code that is managed in parallel with the application, parameterized as necessary. For Azure specifically, ARM templates and Bicep language templates are the native tools that are available within the platform to support this. Cross-cloud and multi-cloud customers may choose to use a tool such as Terraform that allows using one tool for all of their deployments. Microsoft has an initiative known as Azure Verified Modules at https aka.ms/avm that are encapsulations of Bicep and Terraform modules or deployments that make it easier to deploy resources in a best practices compliant way. Ultimately, a landing zone would be deployed through platform automation, which fits when you consider them as repeatable, controlled deployments. Okay, so let's summarize. There are 8 interrelated design areas that are tied to a use of landing zones for ISVs, multi-tenant landing zones. They are Azure billing and Microsoft Entra tenant considerations, identity and access management, resource organization, network topology and connectivity, security, management, governance, and platform automation and DevOps. As an ISV, successful deployment needs to take all of these into account as part of their planning and their execution to really get a proper landing zone environment out there for multi-tenant use cases. Thank you for watching, and I'll see you next time.